Thanks, everybody. Just to give you some idea about me, I have two hats. I am the CTO of DataTrails. We provide transparency services commercially, but I'm also co-chair of an IETF working group working in this area, which is most of the topic of this talk. But to give you a different kind of better idea about me, here's a little section from some of my personal library and a section of the floor of my study. Just to sort of frame why I think, well, why I'm here and why this is interesting, and try and stimulate some conversation really for tomorrow, for the breakout sessions, for the socials, whatever else, about really what we're trying to achieve here and how we can help each other achieve it. So a couple of the things, especially when I started in this, which is as long ago as many of you, surveillance is kind of ubiquitous with transparency in some sense, particularly in classic literature. But to grossly misrepresent a quote from one of these books in particular, one of the takeaways from David Brin is that if you're worried about surveillance, then maybe the problem isn't that too many people have access to transparency and information, but too few. And actually, in order to fight back, if we can have reciprocal transparency and accountability, we'll be in a much better space. And what I'm trying to do really is to try and get transparency tech into as many places as possible, as many applications, as many areas as use data as we can. So remembering that, of course, again, grossly misrepresenting a quote from the Trillion docs, that transparency and transparency tech is really about being an observatory, not a policeman. We're not looking to prevent stuff from happening, but rather to expose things that are happening. So the way that we view transparency tech, it's generally useful. Anybody using data typically worries about these classes of problems, either backdating something, forging something, shredding something, or denying it ever happened when things go wrong. So in a sense, you could just have a single implementation of transparency and it would solve these problems. That would be great. Problem is, the details matter. And I hurriedly changed this slide because our keynote provided such a good set of examples of what the applications are. And interestingly, when you look through these things, supply chain attacks, so the kind of areas that I work in, my company works in, are as varied as tracking nuclear materials moving around to software transparency, through all sorts of things, even AI models and data sets. It's all there, but they require us to make a whole ton of trade-offs, and those trade-offs go deep into the technology when it comes to operating at scale, when it comes to actually paying real money and real salaries to run them and things like that. So what are we going to do? Are we failing open or closed? Are we using privacy by design? And this is a really thorny one, because it's like in one case you want everybody to be accountable. In other cases you want absolutely no linkability between two attestation statements. I mean, how do you build that in a way that's defensible? We've got things like timeframes and long-lived things. We've got auditability. Again, big debates we've already heard about public versus private logs. Artifact availability is a huge one. So something that often comes through that I'm interested in solving and leaning on the combined wisdom of the room is, like, there's a huge difference between saying, I've got this thing, is it genuine? To searching a log saying, tell me everything you know that's genuine about some topic, to, well, I don't even know where to look. And all of these are valid use cases, but again, one true technology, one set of things, one implementation to answer all of those types of questions is just really hard. And then there's the topic of log replication, which again we've heard quite a lot about, and comes to the question of auditability, but it also comes to another set of trade-offs with, how quickly can I do this, how completely can I do this, how much does it cost the auditor to implement this thing versus the shipper or the service, which really begs the question, when people are looking at transparency technology or standards or implementation, you say, which one's better? And the answer is always, well, it depends what you're doing. It's my favorite version of the which one's better slide. Well, I don't know. You can pick which one you think is Tesla on there, but maybe it's the showroom. The showroom's probably the nicest thing in there, actually. So what we need, I think, is a bunch of building blocks. to enable transparency systems to be built out of the best set of those trade-offs. And I think the sort of thing that I'm looking to do, especially with my standards hat on, and again looking forward to the breakouts and the conversations tomorrow, is I think you always need more than one, but not very many options, just to hit that right set of trade-offs. So you can have the sort of really super privacy-oriented things, the really super scale-oriented things, the really super whatever cheap-oriented things, whatever it is. You need a few options, but not that many. So one thing that I want to talk about and quickly introduce, I know some people in the room already know about this, but one significant option and a place where a lot of this thinking and work is being done is in the IETF. And note that it's not a massive curveball, because IETF SCIT was actually imagined originally in part as an extension and a generalization of CT. So 9162 is the current CT version 2. And essentially what it designs is an architecture reasonably pluggable, building block based, scalable, where issuers can make statements about artifacts, might be an SBOM, might be a binary, might be a firmware, it doesn't matter. They put it in a nicely defined cryptographic envelope and then ship it off to a transparency service where it gets packaged up and put in a receipt. What that looks like in practice is you can put basically anything into a well-defined structure for what a statement is. It gets signed in some way, which is then well-defined and parsable. It then gets put onto the log, and what you get out of it in the end is what we call a transparent statement, which is exactly what we've seen a couple of times before earlier today, which is basically the statement with the signature with an inclusion proof, and a reasonably efficient compact inclusion proof that comes straight back to you so that you can hold it in your hands and then do whatever you like with it. But it means that you know that your thing is now on the log. And the benefits of these standards is that they're very small and compact, they're easy to handle. We've built one and it's quick. So all of these concepts we've heard and the things that already work and are implemented in CT and KT also work here in a general sense. And there's lots and lots of opportunity for interoperability. So there is code here as well, just to suggest it does actually work. And what I wanted to say on these particular highlights is just to pull out that this isn't like a brand new thing all its own either. This is based on all of those same building blocks that CT and others use, so it's all using COSI, CBOR structures, things like that. So it's built on the same base, it's using the same principles, just a place where we're applying the thinking on generalization and use case expansion. So where's the interoperability? Well, I think the interoperability opportunities are in every single one of these places, right? So even in the artifacts, you've got questions on things like SBOMs. That's a lingua franca, that's fine. Maybe we want to talk about things like that. I'm not so interested myself, but it's a thing to think about. But then definitely by the time you get to things like structuring the messages and having efficient parsers, when you get to things like the signatures, we have even simple issues like algorithm registries. So we've heard some very opinionated talks today about only having one suite. That's not going to be enough in the end. So when we look at expanding suites, how do we do that? Well, we've got a registry already in IETF, so let's use that. Then you've got the log formats. Hopefully Robin will be doing a lightning talk on Friday about log formats. But yeah, we've got all these questions about tiles versus Merkle mountain ranges versus flat logs. They all have their place, they all have their benefits, and picking the right one for your use case shouldn't mean that you lose the best of all those other things. Having it pluggable, having it interoperable just makes sense. And then finally you've got these areas here with the replication, the verifiers, the auditors. I really liked the suggestion from the last talk that we could have all of our logs being monitored and published in an independent third-party service. Sounds great, let's do that. So all these questions of how do I achieve that and how do I get lots of people on board can only be easier if we agree some small number set of ways of doing this that just makes the adoption so much easier. We have the open source code that's so much easier, and it'll just happen better. So obviously there's loads more animals in the zoo. It's not just SCIT, it's not just IETF. There's a lot of work going on in ITU, C2PA, CAI, that sort of thing. There's obviously all of the OpenSSF. So there are lots and lots of places where this work could happen. But personally, I'm here with knowledge and interest in IETF SCIT, so if you guys do as well, or have any better ideas, please do have a chat in the halls. So, thanks very much.